In this problem, we're going to look at a calorimetry situation. In particular, I'm looking at this block of aluminum metal that starts off at a relatively high temperature and is being allowed to cool down to a lower temperature. And I'm going to want to figure out how much heat is being released as this takes place. Now I noticed that the mass was given in pounds, and I know probably when I go to solve this, I'm going to want to get things into the metric system. I want to get pounds into grams, so the very first thing I do is a simple conversion. I look on my conversion sheet, I find out that there are 453 grams in a pound, so I know I really have 1,700 grams of aluminum. Since all I'm doing is allowing this metal to cool down, then I'm going to use my old reliable equation, Q equals mc delta T. This equation we've used many times. It is only employed when temperatures are either rising or falling and there are no phase changes taking place. So then I go back into my equation and I start plugging in the values that are known. I know the mass is 1,700 grams. I go to my heat table and I look up the specific heat of aluminum, 0.216, and I know to get the change in temperature I take T2 minus T1, which obviously is giving me a negative value, so my final answer is negative, in this case negative 46,000 calories. I know that this is an exothermic process. Heat is being released. Now, I got to check back in the problem, though. They didn't want the answer in calories. It came out in calories because the specific heat was in calories. So therefore, I'm going to have to do one last step, and then I'm going to have to convert calories into joules. I know there's 4.818 joules in a calorie. I multiply the two values, and I end up with a negative 1.9 times 10 to the 6th joules of heat were released in this problem.